Matt Armstrong built his audience the hard way. No glossy reveals, no finished cars rolled out under spotlights. Instead, he bought crashed, salvaged, write-off supercars and rebuilt them from the ground up, entirely on camera. Every mistake stayed in the footage. Every failed repair made the final cut. That transparency was exactly what set him apart. Over time, the projects grew in scale. A totaled Porsche GT3 RS. A destroyed Lamborghini Aventador SVJ. An Aston Martin DBX that had been fully submerged underwater. He even rebuilt a Lamborghini, one of the most electronically complex hypercars ever produced, and got it running again. Each project pushed further into territory most independent garages would never touch. Then came the Bugatti. The images spread fast. A Bugatti Chiron Per Sport, one of fewer than 60 ever built, had been heavily crashed, and the damage was immediately recognizable to anyone who knew what they were looking at. This was not a routine supercar accident. The Chiron Per Sport is Bugatti's track-focused variant of the standard Chiron. Where the base car is built around outright top speed, the Per Sport was engineered for handling precision, revised gearbox ratios, aggressive aerodynamic updates, and a chassis tuned specifically for cornering stability at extreme speeds. Beneath the bodywork sits Bugatti's 8.0-liter quad-turbocharged W16 engine producing close to 1,500 horsepower. It accelerates from 0 to 60 miles per hour in just over 2 seconds. New, it costs upward of $4 million. Wrecked Veyrons, the older model, were already trading for over $1.5 million. A damaged Chiron Per Sport was in a category of its own. The crash damage was severe. The front end had taken a direct impact. Suspension components were collapsed and pushed out of alignment. Cooling systems were destroyed. Structural elements at the front of the car were visibly compromised, and carbon fiber body panels had shattered across multiple layers, exposing sections of the car never meant to be seen. But the most serious concern wasn't visible at all. The Chiron Per Sport is built around a carbon fiber monocoque, a single-piece structural shell engineered to handle extreme forces at speed. Carbon fiber doesn't fail the way metal does. A violent impact can create internal fractures that leave no trace on the surface, but silently compromise the entire structure. Once that happens, manufacturers almost universally classify the chassis as beyond safe repair. Verifying its integrity requires specialist equipment and factory-controlled conditions that simply don't exist outside Bugatti's facility in Molsheim, France. Normally, a crash of this magnitude ends the same way. The insurance company writes it off, the payout is processed, and the vehicle is sold for parts or scrapped. The owner, Alex Gonzalez, made a different call. He bought the car back from the insurance auction and sent it directly to Matt Armstrong. The early stages of the rebuild were extraordinary to watch. Damaged components were stripped, assessed, and either repaired or replaced. Systems that initially seemed impossible to restore were gradually brought back. The engine, transmission, and core mechanical structure were all addressed methodically. After months of work, Matt Armstrong's team had done something most experts considered unrealistic. They had physically rebuilt one of the rarest hypercars in existence. Then the car refused to start. Modern hypercars don't operate on mechanical recovery alone. Every major system inside the Chiron is governed by a network of electronic control units that communicate constantly with each other. The engine doesn't simply start because all the parts are correctly installed. It starts when every module in the network confirms that conditions are safe, verified, and aligned. That's not a bug in the design. It's a deliberate feature, one that protects performance integrity at extreme speeds. But it also makes independent repair exceptionally difficult. As Matt Armstrong's team moved into final testing, some systems responded normally. Others didn't. Certain modules appeared locked or restricted, returning inconsistent diagnostic signals that didn't point to any single failed component. The mechanical rebuild was complete. The digital rebuild was not. And that's when the situation went public. Bugatti CEO Mate Rimac entered the conversation directly. His position was measured but clear. The Chiron platform is engineered to tolerances that depend entirely on factory-level calibration tools. In his view, what was being shown online did not reflect how the car was designed to be serviced or validated. Independent rebuilds, at that level of complexity, simply weren't something the system was built to accommodate. The response was immediate. For many viewers, this was the first time a manufacturer CEO had publicly challenged a YouTube rebuild in real time. It was no longer a technical dispute between engineers. It had become a very public argument about what independent automotive repair actually means and where its limits sit. Matt Armstrong didn't respond with statements. He kept filming. What followed was some of the most impressive problem-solving the channel had ever documented. When official replacement parts were unavailable through Bugatti's tightly controlled supply chain, the team reverse-engineered solutions from scratch. Damaged components were removed, digitally scanned, and recreated without factory support. Then the W16 fired. After months of reconstruction, the Chiron Per Sport ran again under its own power, not on a test bench, not on a dyno, but in the workshop, fully assembled. It was a moment that carried real weight. The engine wasn't just started. It was operating within expected parameters on a car that most of the industry had dismissed as unrestorable. But what came next revealed that starting the engine was only part of the battle. Even after the W16 was running, the car remained in an unstable state. Warning messages appeared without clear triggers. System behavior during testing was inconsistent. Nothing pointed to a single broken component. Instead, the car behaved like a machine that had been restored physically but hadn't fully accepted that restoration in its software. The Bugatti was operational. It was not complete. That distinction quietly changed the entire conversation around the project. Viewers began to notice what was really being revealed here, not just the engineering difficulty of rebuilding a hypercar, but something more fundamental. Even after every damaged panel was replaced, every wire reattached, and the engine returned to life, the car still operated as though it needed internal permission to function normally. Certain behaviors remained gated behind systems that only Bugatti could fully unlock. Which raised an uncomfortable question. If you legally own something, physically restore it, and it runs, but it still doesn't behave like it's fully yours, what does ownership actually mean? The Bugatti wasn't the only hypercar in Matt Armstrong's workshop raising these questions. The Ferrari 296 GTB project had been running in parallel, and it told a different, and in some ways more troubling, version of the same story. The Ferrari had been recovered from Cyprus after a serious crash. Unlike the Bugatti, the mechanical damage was relatively manageable. But the car simply wouldn't start. Despite months of troubleshooting and over $20,000 spent on a new battery system alone, nothing moved the needle. Ferrari initially provided little support, leaving the team without a clear path forward. Eventually, Ferrari did intervene and quickly identified the cause. The electronic handbrake had been disconnected during the crash, and a faulty haptic start/stop button on the steering wheel was preventing ignition. Two relatively minor electronic faults had locked a physically intact hypercar in place for months. Once those issues were resolved, the Ferrari came back to life. Matt Armstrong completed the build with a 296 Challenge-inspired body kit, a redesigned front bumper, enlarged diffuser, and a substantial rear wing, creating one of the more striking restorations the channel had produced. But the Ferrari, like the Bugatti, never fully settled. Modern Ferrari platforms are built as tightly integrated electronic ecosystems. For the car to be considered fully operational, internal software conditions must be met, conditions confirming that every system is aligned exactly as the manufacturer's calibration expects. Physical repair alone doesn't satisfy that requirement. Full functionality depends on a validation process that, in most cases, only Ferrari can authorize. This is where the Ferrari case moved beyond the Bugatti conversation. The Bugatti raised questions about sourcing, complexity, and whether a hypercar could physically be rebuilt outside the factory. The Ferrari introduced something more structural, the idea that even when the rebuild is technically complete, the system itself can still withhold full operation. That's the point where Elon Musk stepped in publicly. His comments weren't specifically about Matt Armstrong or the Chiron. They addressed the broader principle. that software embedded in vehicles purchased by consumers creates a layer of manufacturer control that persists long after the sale is complete. He framed it as a question of ownership rights, and his visibility ensured that the argument reached far beyond automotive communities. For mate Rimac and Bugatti, being named in that context on a global stage was not a comfortable position. For Ferrari, whose rebuild was still unresolved when Musk weighed in, the timing was equally awkward. What began in an independent workshop had become a serious, public conversation about who really controls a vehicle after it leaves the factory floor, and whether the answer to that question is about to change.